we want to find out if this series converges or diverges, so I'm going to use the ratio test. With the ratio test, we take the limit as n approaches infinity of the absolute value of a sub n plus 1 over a sub n. So what we're going to do here is we're going to plug in n plus 1 for all n's in that numerator, and then multiply by the reciprocal of this. So the numerator is this thing, 1 times 3 times 5 times dot 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 times 2, and then we have n plus 1 where we see an n, like that. That's going to be our the numerator of the numerator. So this is dot 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 times 3, and then we have an n, so we plug in n plus 1 into that, like this. And so that's our numerator. And then we're going to divide, which would be the same thing as multiplying by the reciprocal. We're going to divide by this entire thing. So just imagine that I went ahead and rewrote that in there. So let me rewrite this so that we're multiplying by the reciprocal. So I'm going to give myself more room and multiply by that reciprocal. So this is 1 times 3 times 5 times dot 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 times 2 times n plus 1 minus 1 over 2 times 5 times 8 times dot 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 3 n plus 1 minus 1. And finally, we multiply by the reciprocal, which is 2 times 5 times 8 times 3n minus 1 over 1 times 3 times 5 times 2n minus 1. Okay, now we can start to, well, before we cancel stuff out, let's distribute this. So this would be 2n plus 2 minus 1, which is 2n plus 1. That's 2n plus 1 in there. 2n plus 1. And this is 3n plus 3 minus 1, which is 3n plus 2. 3n plus 2. And now we can start to cancel stuff out. So what can we cancel out? Well, we can notice that this is going up by 2's. Like we have 1 times 3 times 5. So that means that the previous term to this is if we had subtracted 2. So that would have been 2n minus 1, because that's 2 less than this term. And this cancels out with this, and also this cancels out with all of that. So that's what we have there. This is obviously going to cancel out with this. But actually, we also have 3n minus 1 canceling out, because that's hidden in here. 3n minus 1. Because that's 3 terms less than this one. And look, we're going up by 3 each time. 2, then 5, then 8. So that means that this had to be 3 less to get to this one. So that's going to cancel out with this one. And now we are left with the limit as n approaches infinity of 2n plus 1 over 3n plus 2. And this is 2/3. We could divide everything by n just to make sure, but we have the same power in the numerator and the denominator. At this point, you should know this is 2/3. This is 2/3 when we take the limit as n approaches infinity, and this is less than 1, which means that by the ratio test, this converges.